This is a video going over the Foundations of Algebra Unit 1 practice test. Please feel free to skip to the question that you might be struggling with. You do not have to watch the entire video. Question 1 asks you to complete the list of perfect squares. Some of them are already listed. 1 is the first perfect square because 1 squared, or 1 times 1 is 1. 2 squared is 4. 3 squared, or 3 times 3 is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. 15 squared is 225. 16 squared is 256. 17 squared is 289. 18 squared is 324. 19 squared is 361. And 20 squared is 400. Now, if at any time you weren't sure about the correct answer, what you could do is you could multiply the two values to ensure that you were correct. Let's say you had doubts about 324. We could do 18 times 18. 8 times 8 is 64. 8 times 1 is 8. Plus the 6 is 14. Done with the 8. 1 times 8 is 8. 1 times 1 is 1. So that's 4. 12. Carry the 1. 324. So you don't necessarily have to have them memorized, but you have to know you could get the answers by doing your multiplication. The second question asks you to graph the following square roots on a number line. The square root of 25 is equivalent to 5. The square root of 16 is equivalent to 4. And the square root of 9 is equivalent to 3. Make sure you number your number line so you know what your interval is. So we'll number 1, 2, 3, 4, 5, 6, and -1, -2, -3, -4. The square root of 25 is equivalent to 5, so I'll put the square root of 25 right there. The square root of 16 is equivalent to 4. And the square root of 9 is equivalent to 3. So I'd put the square root of 9 right there. Question 3 asks you to evaluate. This is the reverse of the process we did in question 1. The square root of 100 is 10. The square root of 256 is 16. The square root of 81 is 9. And the square root of 196 is 14. Remember that square rooting is not dividing by 2. Question 4 asks you to identify any true statements, and the ones that are not true, please indicate why they are not and correct them. The square root of 100 is 10. That is a true statement. We just did that in question 3. The square root of 30 is not equivalent to 15. What this student did was they divided, so the square root of 30 is not equivalent to 15. You'd have to write this as the square root of 225 in order for it to be equivalent to 15. The square root of 121 is 11, but it's not 11 squared, so this would be another incorrect one. It should have read the square root of 121 is equal to just 11. And the last example, the square root of 225 is equal to 25. Again, close, but that's not true. We just established on this one that the square root of 225 is equal to 15. If you felt like it, you could write this again, or if you want to be adventurous, one of the square roots we haven't covered is 25 times 25, which is 625. We certainly don't expect you to know that one. Question 5 says the area of a new trailside playground in the shape of a square is 225 feet squared. So inside this square is 225 square feet. What are the dimensions of the playground? Of course, the word dimensions are asking for the length and width. Now, if we know it's a square, we know that this length and this length are the same. Therefore, this is a simple square root question asking for the square root of 225, which is, as we've mentioned, 15 feet. So it's 15 feet by 15 feet if we're looking to write the full dimensions of the square playground. Moving on to section 2, which covers powers of 10. The instructions ask you to write a negative exponent as a fraction and as a decimal. You may use calculators for this section. We know that a negative exponent does not make things into a negative. What it does is it indicates that it's in the wrong position. Therefore, we want to move it to the denominator, and now it becomes positive. Now that is a fraction, but that's not the fraction we're looking for. We're looking for the fraction in its evaluated form where 10 to the first power is equal to 10. Now 1/10, you can use a calculator, 1 divided by 10, and you will get 1/10. You also should know that your place value, your tenths place, is the same as 1/10. You may type this into your calculator, and you might get equivalent values. Similar, on line number 2, it says 10 to the negative 5. This would be 1 over 10 to the positive 5. Because a negative exponent doesn't make things negative, it just moves it to the denominator, and now it's positive. As you all know, 10 to the 5th power is not 50. It's 10 times 10 times 10 times 10 times 10, which is great, but that's not the fraction we're looking for. We're looking to actually evaluate 10 to the 5th power, which is 100,000. So this would be my equivalent fraction, which if you use a calculator, but you also might know this is 100,000, tenths, hundredths, thousandths, 10,000ths, 100,000ths. You might be tempted to say it's 5, so I'll put 5 zeros, but it's not 4 zeros. It's only 4 zeros. Example number 2 asks you to identify any of these in the 6 choices that are equivalent to 10 to the negative 2. 10 to the negative 2 is a negative exponent question, which does not make things negative. Since we know that negative exponents don't make things negative, if we quickly look over our options, we will see that there is an example that made things negative. That is not a true choice. We can immediately eliminate any negatives. We know that a negative exponent does move it to the denominator. And 10 to the 2nd power is, of course, 100. So it's 100th, which is 0.01. We need to explore going from here to here, though, because 10 squared can be written as 10 times 10. And sometimes we can write that as 2 separated fractions being multiplied, 1/10 times 1/10. So any of these options up here are possible when we're looking down here. 100th is right there, which is not the same as 1/10, so we can eliminate that. 1 over 10 squared, we see that option. 10 times 10 is 100. That's definitely not what we want. And we already established that it could be 1/10 times 1/10, which is that value. So it looks like it's all 3 values in the top row. Question 3 asks you to identify the exponent that you would need to plug in here to correctly complete this equation. 0.0000001 is equal to 10 to the what power? Now the trick is really how many times the decimal point moves from the number 1 is the value of the exponent. So let's count how many times you would have to move this decimal point until we get the correct number. 1, 2, that's 0, 1, which is not correct. 3, 4, 5. So we're looking at 4 zeros. We want 1, 2, 3, 4, 5. Looks like 6 zeros. So since we want 6 zeros, we have to keep going. 1, 2, 3, 4, 5, 6, 7 times the decimal moves. Now we have 1, 2, 3, 4, 5, 6 zeros. Checking again. 1, 2, 3, 4, 5, 6 zeros. These are now the same. Again, if you count, the decimal moved 1, 2, 3, 4, 5, 6, 7 times. So the exponent should be negative 7. The other trick, if you notice from the previous example, it's not how many zeros there are. There are 6 zeros, but it's not 6. It's actually 1 more. The exponent is 1 more than the number of zeros that you see. Of course, remember that's supposed to be negative because it is getting smaller. Question 4 said that Jessica wanted to determine which answer was equivalent to 10 to the negative 3. Which answer would you tell her and why? If I was doing this work the correct slow way. We know that a negative exponent moves things to the denominator. 10 to the third power is not 30. We don't have a 3 up here. It's 1. And this negative exponent just becomes positive. 10 to the third power is equivalent to 1,000. So it's 1,000, which is tenths, hundredths, thousandths. These are the two values I am looking for. Unfortunately, some students see 3 as an exponent, so they start looking for 3's in their answer, which of course there is none because these are the two values. 3 does not describe what we're putting in here. 3 describes the exponent. Now, you also should notice, as we've mentioned in class, that a negative exponent does not make values negative. Therefore, if we look at our choices, right away we can eliminate choice A and B because there shouldn't be any negatives. C was simply 1,000 and 100, which are different numbers, different values, so that can't be true. The correct answer is D, which is right here. You probably could have answered this question without having to actually do any work if you just knew that they shouldn't be negative, and 1,000 and 100 doesn't make sense. Section 3 goes over scientific notation. Write the following in standard form or scientific notation based on what they give you. Scientific notation is, of course, a number between 1 and 10 times 10 to some exponent. You need to make sure your number is between 1 and 10, always times 10, and then you write an exponent to indicate if you're getting bigger or smaller. Positive big, negative small, positive big, negative small. This is a big number, so I know I'm going to have a positive exponent. This is a small number, so I know I'm going to have a negative exponent. This is a positive exponent, so I know I'm going to end up with a big number. This is a negative exponent, so I know I'm going to end up with a small number. Positive big, negative small, positive big, negative small. Let's go back and actually do the work. We need to create a number between 1 and 10, so I will do that by moving the decimal point. 1, 2, 3, 4 times to get 1.7. I don't need to add the extra zeros. We don't need to do that. So it's 1.7. Always times 10. Don't forget that. And it moved 1, 2, 3, 4 times. Since I decided it was a big number, it remains a positive exponent. Once again, we need to make this a number between 1 and 10. So we will move the decimal point to 3 times until we get 9.8. Always times 10. In this case, it moved 3 times. And we've established that since it was a small number, it will be a negative exponent. This example over here, bottom left, we have 3.4. The 4 does not say 4 zeros. It means it moves 1, 2, 3, 4 times. We only end up with 3 zeros when we rewrite it. 3, 4, 0, 0, 0, which is equivalent to 34,000. Here's a negative exponent, so I know I'll end up with a smaller number. 3.77, 3 and 77 hundredths. 3 times, does that mean 3 zeros? It means move the decimal 1, 2, 3 times. Now I end up with a small number, as I thought, 0.00377. Question 2 says there are 9,260,000,000 chicken nuggets eaten every 4 weeks in the United States. Maybe this is made up. Mr. Colacello certainly made this up. Write this number in scientific notation. I'm going to take this value. I'm going to move the decimal point until I get a number between 1 and 10, which means I'm trying to get it right there. So let's see how many times it has to move. 1, 2, 3, 4, 5, 6, 7, 8, 9 times. It moved 9 times. Now, obviously, this is a big number, so we know that positive is big. So we have a positive exponent. It moved 9 times. 9.26. We don't need to add all those extra zeros. Times 10 to the 9th power. And moving down slightly to do question 3. It says to put the following from least to greatest in ascending order. What you could do is you could look and, you can convert all of these into what's called standard form. Or you could simply look at the exponents And you'll know that the largest exponent will equate to the largest number. Now, they're all different, so you don't even have to worry about these numbers up front. Now, they're negatives, so we have to think about that. But if you thought that you had 3 times 10 to the 5th, or you had 7 times 10 to the 2nd, this value is going to be larger because moving the decimal point 5 times will make it a bigger number than only moving it 2 times, even if you start with the 7. So keep that in mind. We look for the largest of these exponents. At first, you might be drawn to the -6 until you remember that they're negatives. Therefore, this 4 times 10 to the -2 is actually the largest number. So if we're going from least to greatest, that's going to be our biggest. The smallest will be this one. So 3.1 times 10 to the -6. Next would be the 1.11 times 10 to the -4. Following that is 2.15 times 10 to the -3rd. And lastly, 4 times 10 to the -2nd is our largest value.